Hi there, this is Sharmin here. In this video, I'm going to talk about Big Bang Theory. Georges Lemaître, who was a scientist and cleric and who was the father of the Big Bang model. So Lemaître proposed that the theory consists both the Hubble's observation, that means a universe is expanded over a time, and that means theoretical idea that is universe had a definite beginning point. All right. According to the Big Bang Theory, the universe had a moment of formation when it appeared as an initial fireball. This expanding fireball is often presented as a giant explosion, but these need some rethinking. In the expanding universe, space is expanding so that the galaxy in space are moving farther apart. A better analogy than an explosion is a loaf of raisin bread. The raisins are spread throughout the bread and move farther apart as the dough rises. As the universe continued to expand and cool, matter began to clump. Larger clumps formed galaxies such as our own Milky Way galaxy, which contains hundreds of billions of stars. Galaxies in this stage are quasars. The energy source for quasars, which is probably a supermassive black hole, tends to reduce the amount of energy it emits as it ages. The first generation of stars that formed in our galaxy were mostly hydrogen, another one helium, because that was what we was made during the Big Bang. The nuclear fusion reactions that create stars fuse their lighter elements into heavier elements. When stars run out of hydrogen fuel in their cores, they expand into red giant, which might be about size of Earth orbit around the sun. Stars of about the sun's mass can then fuse heliums to carbon and some oxygen in their cores. These stars will then collapse into slowly cooling burnout stars about the size of Earth that are called white dwarfs. If the white dwarf is more than 1.4 times the mass of the sun, it cannot be a stable with dwarf and collapse into a neutron star. The protons and electrons are squeezed together into neutrons, and the neutron star collapses to about the size of a city. During the transition from red giant to white dwarf, many stars gently blow off their outer layers to form a planetary nebula, which is a shell of gas around a dying star. Stars that are 10 or more times the mass of the sun can fuse elements heavier than carbon in their cores. The extra mass provides enough gravitational force needed to squeeze these heavier elements to undergo fusion until elements about as heavy as iron on the periodic table are made. Iron is the boundary between fission and fusion. So fusing elements heavier than iron requires rather than releases energy. When the iron core builds up in these massive stars, they explode in a humongous explosion called supernova. A supernova releases as much energy in a year as the sun does in its 10 billion year lifetime. There is plenty of energy to make all the elements that will normally not fuse. The supernova also blasts these heavy elements out into space to be recycled into the next generation of stars. The Crab Nebula is the remnant of supernova that occurred on July 4, 1054, the material enriched in heavy elements will be recycled into nebulas such as the Orion Nebula that is in the process of forming new stars. Our solar system formed from a nebula that was also enriched in heavy elements by a prior generation of stars that exploded as supernovas. The core that remains after the supernova explosion collapse into a neutron star. This is a ball of neutrons with a mass comparable to the Sun, but compressed to the size of a city. If the core is more than about 2 to 3 times the mass of the Sun, it will collapse into a black hole. To become a black hole, the Sun would have to be compressed to a radius of fewer than 3 kilometers. A black hole is so highly compressed that its escape velocity exceeds the speed of light. Because they manufacture and recycle heavy elements, supernova play a crucial role in how you got there here. The atoms in your body, heavier than hydrogen, were manufactured in the cores of stars and recycled by supernova explosion. Redshift, our expanding universe. Additional evidence supporting the Big Bang theory is the observed expansion of the universe over time. This expansion is seen as a redshift in the light spectrum emitted by stars and galaxies. Since the patterns for various elements have been established on Earth, astronomers have detected these same emission patterns or spectra of elements on distant stars. The patterns observed are the same as those seen here on Earth, except that the entire pattern is shifted toward the red end of the visible spectrum, in which astronomers call the red shift. The redshift occurs because of a phenomenon known as the Doppler effect. When a redshift is observed, one may conclude that the object is moving away as light waves are being stretched by the increasing distance between the observer and the object. That's all, guys. Thank you so much, and see you soon with another video. Thank you.